Also, when dealing with a regular hexagon, there are some other side lengths, or if we know the side length, let's call this A, then we can know some other things. Well, the diagonal, the distance across here, if you think about how we set this up in that last video, all of these are equilateral triangles, so this distance would be a distance of A, and that distance would be a distance of A as well. So that means this diagonal here, D, would be just 2 times the side length. So we got our first, we can get that diagonal right there. It's just 2 times the side length. Now, the face, or F, the flat, I guess, is what it stands for. The distance from across the flats is a little bit more tricky to find. And we're just going to go ahead and say this is approximately 1.732 times A. You can get it more exact if you use the Pythagorean theorem, again using the fact that you have some equilateral triangles here. You take the height of this equilateral triangle and double it to get that the distance across the flats there, if you wanted to do more accurate measurements, but this will be good enough for this class. So that means if we were given any of these measurements, if we're given A, little a that is, D, F, so this is the side length, this is the diagonal, the long way, the diagonal, this is the distance across the flats, or technically if we were given the area, if we were given any one of those, we could figure out all of these other things. So let's fill in the blanks here with the missing dimensions and round to 2 significant digits if necessary. Okay, so if the side length is 2.0, the diagonal length is double that. It will be 4.0. The distance across the flats, well, I'm going to take 1.732 times A. 1.732 times 2, which gives me 3.464. I'm going to round that to 2 significant digits, which means I'm going to call it 3.5. And A, the area of this, I should probably write this right here, is 2.598 approximately A squared. I'm only doing 2 significant digits here, so the 4 significant digits is plenty. So I'm going to take that 2.598 times A squared, 2.598 times A squared, 2 squared is 4. So I end up with 10.392. Rounding that to 2 significant digits, I get 10 with a 0 with a bar over the 0 to indicate that it's actually 2 significant digits there. Alright, for these other ones, if I'm given the diagonal, and it's not easy to go directly to the flat length. So instead what I'm going to do is, given the diagonal, I'm going to go through the side length first. I'm going to figure out, okay, if my D is 2 times A, then that means A must be 1/2 D, or D over 2. So just divide both sides by 2, and so I can get 0.75 divided by 2, giving me 0.375. I'm going to round that off to 0.38. Now, this does actually bring up an interesting problem here. 0.38, so what I've done here is I divided by 2 and then I rounded this. If I was to use this 0.38 for these other measurements, I'd be using something that I rounded once and rounding it a second time. And in general, that's not a good thing to do. So what I'm going to do is I'm just going to remember this 0.375. I'm going to remember that that's the value I initially got here, and in the formulas for the flats and the area, I'm going to be using the 0.375, and then I'll round them off to 2 significant digits. So let's see, for the distance across the flats, let's see what number I need to use there. 1.732 times 0.375, which gives me, rounding to 2 significant digits, I'll call that 0.65. And the area here is going to be 2.598 times A squared, and A, well, at least the value I'm going to use is 0.375 times 0.375. I guess I could actually type in squared on this calculator. It's just oftentimes easier to multiply the thing. So we get 2.598 times A squared, or 3.75 squared, which gives us 0.365 whatever. And if I round that to 2 significant digits, it's going to be 0.37. This was in inches, this was in inches, this would be square inches. I didn't show on these, but the distance across the diagonals, these would be all linear measurements. The area would end up being square meters. And a similar sort of thing would happen here for flats. If I'm given the distance for flats, remembering that this is, what was that, 1.732, F equals 1.732A, that means A is equal to F divided by 1.732. 6 divided by 1.732, and this is kind of a little bit of an obnoxious number to plug in every single time. So if you know how to tell your calculator to remember things, that would be a nice thing to be able to do. I'm actually not seeing how to do it on this calculator, so I'll just have to type it in. So first off, I'll write down what this is, rounded to 2 significant digits. It's 3.5 millimeters. But I'm going to use this value for my, use the unrounded value to find out what my D is. So double this, we should get 6.9 millimeters. And then if I was to take that value, I think I can go... click on it? Yeah, okay. So I can pull it back up on this calculator just by clicking on it. So to find the area, I should do 2.598 times 2 point, it doesn't like letting me type sometimes, times this number squared. Oops. Which gives me 31. Yeah, I'll just round that off to 2 significant digits, so 31 square millimeters.